Hello friends, let's evaluate this integral. Hmm, how are we going to do this? Okay, so this integral, I can rewrite this as, let me just copy it. Okay, so I can rewrite this function inside, this one inside here, the square root of 1 plus x. I can rewrite that as 1 plus 2x to the power of 1 half. Then I have 2 dx, right? Okay, that's the first step. What's the next thing I can do? Okay, I can do what is called a u-substitution. Okay, so the complex part of this integral, what's the complex part of this integral? Is this part, right? Like, we really don't know. We can't use the normal integration technique to integrate that. Because of the power 1/2, we can't even multiply the 2 that we have here. These two, we can multiply it with this, right? So that's the complex part. So usually when you want to do a u substitution, right, you um you kind of look at the complex part of the integral, the part that is kind of looking complicated, and that's what you call your u. So we are going to do it, and then I think it's going to become clear. So I'm going to take my u to be um 1 plus 2x. So my u is 1 plus 2x, not everything, not 1 plus 2x to the power of 1/2. My u is just going to be what is inside the parentheses. Now, the next thing I'm going to do is that I'm going to take the derivative of u, which is du dx is just going to be 2, right? So um, if you cross multiply, you get du is just going to be 2 dx, right? Just cross multiply. Now, you go back to your function, to the integral, right? And then you look at the integral. I have I have 2x, I mean 2 dx in the integral, right? I have this part. And then if you look at what I just did, I also have 2 dx here. So instead of writing 2 dx, and I know that 2 dx is equal to du, right? So instead of writing 2 dx in the integral, I can replace it with u. That's why it's called u substitution. So I'm going to write up here u substitution. Okay, so I'm going to replace the 2 dx with u, right? I'm going to replace it with u. And recall that my 1 plus 2x, recall that 1 plus 2x is what? U, right? So I'm going to have u to the power of 1/2. Then I'm going to replace 2 dx with du. I have something so simple, right? Now I can easily apply the fundamental integration technique, which is you add 1 to the power and then you divide by the new power. So this is just going to be u to the power of 1/2 plus 1 over 1/2 1 plus c. Since now I have actually performed the integration, I can add a constant of integration. The c there is called the constant of integration. So this is just going to be u to the power of 3/2 over 3/2 plus c. This is just going to be 2 u to the power of, and just simplifying, over 3 plus c. But recall that from the problem, there was no u in the problem. I named 1 plus 2x u, right? I named it u. So instead of having my u uh, instead of having u, so like over here I named 1 plus 2x to be u, right? So my u is actually 1 plus 2x. So instead of having u, I can have is going to be 2 1 plus 2x to the power of 3 over 2 all divided by 3 plus c, and this is going to be the solution. Yeah, so I'm just quickly going to do a quick recap. So I want to evaluate this integral. Then I rewrote it, instead of having the radical sign, I rewrote it as 1 plus 2x to the power of 1 half. And that's the kind of complex part of the integral. So I just made u to be equal to 1 plus 2x, took my derivative, and then I cross multiply. I got du is equal to 2 dx, and I just substituted everything back in to the antiderivative, and I got my answer. Yeah, that's it. Hope that helps. Thank you.